today we are going to see how to solve the homogeneous differential equations. And what is homogeneous equation? The homogeneous equation is in the form of dy by dx equal to f of x comma y by g of x comma y. So here we cannot separate the variables. It's a variable separable method, we can separate the variables. But here it is not possible to separate the variables. Separating variables means where you got a dx you will take all x terms, and where you got a dy you will take all y terms. But here it is not possible. In that case we have to go for this method. So it will be in the form of dy by dx equal to the combination of x and y which cannot be split. Okay, right. Now our substitution will be put y equal to bx. Put y equal to bx. So differentiating with respect to x. If I am differentiating, differentiation of y is dy by dx with respect to x. This is product rule. V is one variable, x is another variable. Keeping v as it is, differentiation of x is 1 plus keeping x as it is, differentiation of v is dv by dx because we are differentiating with respect to x. So dy by dx is equal to v plus x into dy by dv by dx. V plus x into dv by dx. So this is the substitution we have to do, and this is another substitution. Put y equal to vx. Simultaneously in the place of dy by dx we have to substitute v plus x into dv by dx. Now we are going to solve the problems. So solve the following differential equation. Solve the following differential equation. For this question, so let us take the first question, dy by dx. The first question is dy by dx equal to x plus y by x. So now you cannot separate this variable. Already it is in the form of dy by dx equal to the combination of x and y. Right. Now, so our substitution is put y equal to vx, and which implies dy by dx equal to v plus x into dv by dx. Simultaneously where you have y you need to substitute vx, where dy by dx you have to substitute this. So in the place of dy by dx, v plus x into dv by dx equal to x. In the place of y, vx divided by x. So v plus x into dv by dx equal to, taking x in common, 1 plus v by x. So cancelling this, we will have v plus x into dv by dx is equal to 1 plus v. So we have v both the sides, we can cancel it off, and what is left out, let's write x into dv by dx is equal to 1. Next we have to go for variable separable method. Okay, so now we can apply variable separable method. So x into dv equal to dx. X into dv equal to dx. What is variable separable method? Where you got dv, we have to bring all v terms. Where you got dx, you have to take all x terms. Here we have only dv, no v terms. So let's write dv equal to 1 by x dx. So now we have separated the variable. Now we can integrate it. So integration of dv is v equal to log of modulus of x plus c. Modulus of x plus c. So this you have got this solution, and it is given in terms of x and y. We got the answer in terms of v and x. So now we have to substitute back. What is that? We have assumed y equal to vx. Now in the place of v, we have to substitute y by x. Y by x. We have to substitute v equal to y by x. So if you are substituting y by x equal to log of modulus of x plus c. If you are bringing it this side, y equal to x into log. I am multiplying throughout by x. X log x plus cx is the general solution. Is the general solution. So of the homogeneous differential equations. We'll do the second question. The second question I am taking is x squared minus y squared into dx plus 2xy into dy equal to 0. Now you can see that it is x and y are mixed up, so we cannot separate the variables. We cannot apply the first method, variable separable method, that I have done in part 1. Right now here we have to go for homogeneous differential equation. For that, first I need to write it in the form of dy by dx. So dy term I am keeping this side, dx term to the other side I am taking. So 2xy into dy equal to minus of x squared minus y squared into dx. Right now we are going to write it in the form of dy by dx. dy by dx means we have to bring dx this side, minus of x squared minus y squared divided by 2xy. So now we wrote it in the form of dy by dx equal to f of x comma y divided by g of x comma y. Now we have to go for the substitution. Put y equal to dx. So which implies dy by dx equal to v plus x into dv by dx. v plus x into dv by dx. Simultaneously we have to substitute. So v plus x into dv by dx is equal to minus of x squared, in the place of y, vx. So y squared becomes v squared x squared divided by 2x into y is vx. Right, now the next thing, minus, I am going to take x squared in common. You can take x squared in common, minus x squared into 1 minus v squared divided by 2x squared into v. 2x into x is x squared. So we can cancel this x squared. Now let me write v plus x into dv by dx is equal to what we have written here, minus of 1 minus v square divided by 2v. Right, now, so I will send the minus in. V plus x into dv by dx. I think you understood this. Right, now dy by dx equal to, send minus in, minus 1 plus v square divided by 2v. Now taking v that side, so x into dv by dx equal to minus 1 plus v square. I send minus in, minus 1, minus into minus, plus v square divided by 2v minus v. So taking LCM that side, x into dv by dx is equal to, take 2v 2v as LCM. That will be minus 1 plus v square minus 2v square minus 2v square. Right, now, so we will write it here. X into dv by dx is equal to minus 1 minus 2v square plus v square is minus v square divided by 2v. So we can write x into dv by dx. Now you can take minus in common, 1 plus v square. Both will become positive divided by 2v. Now we can apply the method of variable separable method. Right, now what will I do first? I will take dx that side, x dv equal to minus of 1 plus v square divided by 2v into dx. We can take simultaneously also. So for your understanding, first we are taking dx that side, next we are bringing y terms, v terms this side. So if you are bringing, I am leaving the minus sign here and bringing here this 2v by 1 plus v square. If it comes this side, 1 plus v square by 2v comes this side, 2v by 1 plus v square into dv equal to minus, I will write here 1 by x dx. Now we have separated the variables, we can integrate it. So you can go for substitution method. The differentiation of the denominator is in the numerator. You can write directly log of the denominator, or else put 1 plus v square equal to t 2v into dv equal to dt. So 2v into dv is dt. So now I will write this as 2v dv is dt divided by t equal to minus integration of 1 by x dx. So if I am applying the log, if I am integrating it, so integration of 1 by t dt is log of modulus of t, the base is always e. So equal to minus log of modulus of x. Since everything is in terms of log, I am taking the constant also in terms of log. I will take this as log c. Sorry, log modulus of c. You can take simply c also. You can take it in any way, but the simplification will be easier for you. That's why we are taking, if everything is in terms of log, we are taking this also log. So let me bring it this side, log of modulus of t plus log of modulus of x equal to log of modulus of c. So we can skip the modulus, we can write like this. So right, you know that log a base b base e plus log b base e equal to log a into b base e. So I am substituting the formula for this one. So it will become log of t into c. The base is e. You can take here also e. Right. If you are writing log, you need to mention the base. Simply it is ln, natural log, ln of a, any, obviously the base is always e. Right. Now, so which is equal to log of c. So cancelling this both sides, and we have tc equal to tx, it is tx equal to c. Right. Log a plus log b is log a into b, t into x. So now we are going for substitution first. What is t? T is 1 plus b square. So 1 plus b square into x equal to c. Right. Again, we have to substitute. As we know y equal to vx, we need to substitute v equal to y by x. We need to substitute back in the form of y by x. So this is 1 plus, this is v square, this is nothing but v is y by x, means v square is y square by x square into x plus equal to c. So I will finish it here. Suppose if I am simplifying this, 1 minute. If I am simplifying this, I am taking LCM here. X square plus y square divided by x square into x is equal to c. So you can cancel one x here. So cancel x and x. This will be x square plus y square by x equal to c. So which implies x squared plus y squared equal to cx is the general solution of the homogeneous equation. Is the general solution of the homogeneous equation. The next question is, third question. Just a minute. X dy minus y dx equal to root of x square plus y square into dx. We need to find the general solution of this. Right, now we can understand that x and y are mixed up, we cannot separate it and we cannot apply variable separable method. So we have to go for the homogeneous differential equation method. So homogeneous differential equation is in the form of dy by dx one side and all the other terms to the other side. So first I will keep dy term this side and this is dx I am taking to the other side. So root of x square plus y square dx plus y dx. If minus y dx goes that side, it will become y dx. Right, now, so x dy is equal to x dy is equal to, take dx in common, root of x square plus y square plus y into dx. I have taken that side dx out. Right, now we are going to write it in the form of dy by dx. So bringing dx this side and x to the other side. So dy by dx equal to root of x square plus y square plus y divided by x. Right, now this is in the form of dy by dx equal to f of x comma y divided by g of x comma y. Our substitution is put y equal to vx, which implies dy by dx equal to v plus x into dv by dx. Right. Now I am taking this equation, in the place of dy by dx I am substituting v plus x into dv by dx equal to, in the place of y I will substitute vx. So y square becomes v square x square. So root of x square plus v square x square plus y is nothing but vx divided by, we have x term. Right, now v plus x into dv by dx equal to, I am taking in common within the root. root of x squared into 1 plus b squared plus bx divided by x. Right, now v plus x into dv by dx. So outside the root x squared comes, it will become x. Root of x squared is x. Root of 1 plus b squared plus bx divided by x. Right, next. So v plus x into dv by dx is equal to, taking x in common from the numerator, root of 1 plus b square plus b divided by x. So cancelling this, we have b plus x into dv by dx equal to root of 1 plus b square plus b. So we have here also b there. So b goes to upside, will become minus b. Better we can cancel it here only. Right. What is left out? X into dv by dx is equal to root of 1 plus b square. Next we are going for the variable separable method. Now I am going to separate the variables. Let me do it simultaneously. Where you have got dv, I will bring all y terms. So these two I am taking to the other side. So 1 by root of 1 plus b square into dv equal to 1 by x dx. So we have separated the variable. We are integrating it. Integration of 1 by root of 1 plus b square. 1 plus b square into dv. Right, now, so I have the formula. By formula, integration of dx by root of a square plus x square. The formula for this is log of modulus of x plus, what is here, you have to write as it is, a square plus x square plus c. Plus c. So this is formula. This formula I am going to apply for this. So here, if I am comparing this, if I am comparing these two, in the place of a I am having 1. So because no 1 can be written as 1 square. So in the place of a I am having 1. In the place of x I am having b. So I will apply this formula. Log of modulus of x is nothing but b plus root of a squared is 1 square. That is 1 plus b square. 1 plus b square. Replace x by b and a by 1. So equal to log of modulus of x plus, everything is in terms of log, we take constant also in terms of log. So I can write this as log of b plus root of 1 plus b square equal to, I am applying the formula, log a plus log b is log a into b. Log of x into c, that can be written as c into x. C into x. So we can cancel log both sides. What is left out? b plus root of 1 plus b squared equal to cx. Right, now we are substituting for b equal to y by x, because we know that, so y equal to bx, which implies b equal to y by x. We have to substitute back. So this will be y by x, b is y by x plus root of 1 plus b squared is y squared by x square by x square, which is equal to this side you have cx. Right, now, so simplification it is, we are going to simplify this. Right, so y by x plus, I am taking LCM x square plus y square by x square equal to 6. Right, so y by x y by x plus root of x square plus y square divided by root of x square is x equal to cx. So if I am taking LCM as y plus root of x square plus y square by x equal to cx. Bringing x that side, y plus root of x square plus y square is equal to cx square. X into x becomes x square is the general solution. Is the general solution. I think you might have liked this class. If you like this video, please subscribe and press the bell icon for the upcoming video, students. Thank you.